Hello dear students, this is Dr. Aisha Nazuk here. Welcome back to our channel. And today I thought I'm experimenting, and I have shown my face. I've turned on my video so that my dear students can watch while I'm trying to connect with all my viewers and my students. So today we are going to start the topic of discrete probability distributions. The reason I have mentioned here chapter number 6, I'll show you in a while in the next slide that which book chapter 6 are we going to cover in today's lecture. So we will be discussing the idea or the concept of random variable, mean or expectation of a random variable, and then variance and standard deviation of a random variable. So these are the basic concepts that we are going to cover in today's lecture. And if you want to efficiently use these lecture notes or this video, a good idea is that you download the book of Douglas Lind. And in case you're wondering how to download the book, it's very easy to download the book. You can download it from the Genesis library, and I have a guidance video on my channel. And by the way, the channel name is Rao Hub. My regular viewers are well aware of the fact that this is the channel name. The new viewers are welcome to subscribe to my channel and share these videos. You can drop me an email and we can get connected. So we're going to cover chapter number 6 of Douglas Lind book, and as I said that you can download the book easily from the Genesis library. The good part about this book is there are answers available to the exercises at the end of the book. So you may try to solve chapter exercises. You can also focus on the solved examples given in chapter number 6. Okay, so what is a probability distribution? As you know that whenever we have a random variable, first of all, before we explore the idea of probability distribution, we should differentiate what is the difference between a variable and a random variable. So a variable is something that changes. For example, day of the week change. After Monday we have a Tuesday and Wednesday and so on. But there is a fixed pattern, After Monday it's known that it's going to be a Tuesday. So day of the week is a variable, but it's not a random variable, right? A random variable is one whose values cannot be predicted with 100% accuracy, right? Let me repeat, a random variable is one whose values cannot be predicted with 100% accuracy. For example, if you invest in a stock, it's possible that you are going to reap profits, loss, or no profit, no loss situation. So the amount that you earn or you lose from that by investing in that stock, it's a random variable because you cannot be 100% sure about the outcome. So a probability distribution is about a random variable, and how we tabulate or we graphically portray that distribution, we are going to cover that in coming few slides. So first of all, we'll be focusing on discrete probability distributions. By the way, discrete random variable is a variable that can be counted, right? For example, number of people who like a particular brand of deodorant. So you can easily count. For example, you can say that 5 people like that brand, or maybe 10 people like that brand, and so on. So a discrete random variable is a variable that can be counted, right? And so discrete probability distribution is corresponding to a discrete random variable. So we will do, as I said, that we are going to focus on solving some questions rather than just going on exploring the concepts theoretically, because it's rightly said that only there is no shortcut in quantitative courses. You have to practice the maximum. Okay, so the possible outcomes of an experiment involving the roll of a 6-sided die are a 1-spot, a 2-spot, a 3-spot, a 4-spot, 5-spot, and a 6-spot. So those of you who have played the game of Ludo, or they've seen the die, they are well aware of the fact that it has 6 sides, right? So by the way, there is a very thin likelihood that you haven't seen a die in your lifetime, but if that's the case, you can simply type in Google Ludo die image, and you can see that there are 6 sides of a die, and in some cases the dots are printed on the die, and while in other cases a number is printed. So anyway, it has a six-sided. So we have to develop a probability distribution for the number of possible spots or dots, and then portray the probability distribution graphically, and what is the sum of the probabilities. Okay, before I explain these ideas, so you have to keep in mind, as I said, that there are 6 possible outcomes. Like if you throw the die, it's possible that the die lands on a side which has 1 dot on it, or it may land on a side which has 2 dots in it, and so on. So there are 6 possible outcomes of this discrete random variable. And why it's discrete? Because I can count the number of dots, right? I can count that if I toss the die, how many dots were there, so I can easily count. So it's a discrete random variable. Okay, so what you have to keep in mind, even before I explain you how these probabilities are calculated, if I write p of x, that means probability of random variable taking a particular value. So the probability that the die lands on a side where we have only 1 dot, that probability is 0.1667. So how is it calculated? I'll come to it later. What you have to keep in mind, that the sum of probabilities should always be equal to 1, right? Sum of probabilities, that if I add all these numbers, it should always be 1. Why? Because we have a axiom of probability that the total probability is always equal to 1. Because if I enlist all possible outcomes, it is actually the entire sample space, and the probability of the entire sample space is always 1. Second thing that you need to check is no probability should be negative, and no probability can be greater than 1, because probability, even if an event is impossible, its probability is 0. Probability can never be negative. Similarly, probability cannot exceed 1. So these are the 2 basic conditions that you can check in any distribution. Now how I have assigned these numbers, you see that there are 6 possible outcomes, and each one of these are equally likely. We are saying that it's a standard die. We haven't done anything to fine tune the die in a manner that the likelihood of landing on 2 is more, and so on. So it's a standard die. So that means the chances that it will show 1 are equal to the chances that it will show 2 dots, and so on. So there are 6 possible outcomes, and each one of these can be assigned a probability. If I express in the form of fraction, that probability is 1 by 6. So if you divide 1 by 6 and you report it to 4 decimal places, it is equal to 0.1667. So that's how I calculated or assigned probabilities to these outcomes. Once again, you can easily add all these numbers and you will get 6 by 6, so the total probability will be 1. Now the question said, if you refer back, that you have to develop the probability distribution. So that you have done, that you have enlisted all possible outcomes and their corresponding probabilities. So you have developed the probability distribution. Part B is that you have to portray the probability distribution graphically. So what you have to do, on the y-axis you will show probability, whereas on the x-axis you can show the outcomes. So outcomes are from 1 to 6. So you can see against 1 I have plotted a number which you can see it is 0.1667, and so on. So we have seen that for all the outcomes the likelihood is same. So this probability distribution, by the way, how I have drawn here this probability distribution is simple, that I entered all these data in Excel and then I went to insert. I'll show you there. So for example, we have probabilities distribution of a die, right? So here I made this graph, and how I made this graph, I selected these values, right? So I haven't selected the column headings, so I've just selected the data, and then I go to insert. So I go to insert, and then insert, I have this option of scatter, and I can click this, so you can see that this chart is made. So now you can easily add chart title by double clicking here, and you can you can type here. So by the way, I'm typing something here. You can type any title you want, and by the way, you can also label the axis. So if you click on this plus sign, you can choose exist title, and if you click on you see data labels. Once you click on data label, you can see that these numbers appear. So each dot is, it's a realization or an observation against the probability 0.1667. And these exist title you can select, and you can type here. For example, I've selected and I'm typing probability in short. I can click here, and I can type here as well. For example, here I type number of dots. So that's how you can easily make the plot in Excel. So this is exactly what I was discussing here on this slide. So this is the probability distribution of a standard die, and you can see that each outcome has an equal probability. In other words, each outcome is equally likely. So that's how we have made the probability distribution. Then the question says, what is the sum of the probabilities? That is very simple. You just add all these probabilities, and that will be equal to 1. So whenever the probability distribution is complete and proper, the sum of the probabilities should always be equal to 1. If it is not, that means it's not a proper probability distribution. Okay, so now coming back to the basic definitions that I have to some extent already discussed, but it will be a quick refresher. So random variable is a quantity resulting from an experiment that by chance can assume different values. For example, if you randomly go and ask some person whether that person likes chocolate or not, you can expect an answer yes, no, or maybe the next person says maybe, sometimes I like it, sometimes I don't. So there are different possible outcomes of this experiment. So whenever you perform a random experiment, the outcomes of that random experiment could be called random variable. So random variable could be discrete or continuous. As I have already told you that if you can count something, that's a discrete random variable. And if you cannot count something but you can measure it, then it's a continuous random variable. So we will do some practice activities here, very simple ones, to set the foundations for the difference between discrete random variable and continuous random variable. So let's say the number of new accounts established by a salesperson in a year. See, we are counting the number of accounts, right? We are not counting the money in accounts. So the number of accounts could be, let's say, 0, 1, 2, so on. So this one is a discrete random variable, right? In part B, we have the time between customer arrivals to a bank ATM. You see, you are randomly standing in front of a bank ATM and you are observing that after how many time customers are arriving to the ATM. So it's fairly possible that after the first visit, the second one arrives after, let's say, 1 minute and 23 seconds, and then the next one arrives after, let's say, 30 seconds. So the time can be anything. In fact, the time is continuously changing, right? You can't count time, but you can measure it on a certain scale. For example, you can measure it on a scale of minutes and seconds, right? So in part B, it's a continuous random variable. Similarly, if I go on, let's say, the last one, because most of these are quite straightforward and you can easily, based on the explanation that I've given you, you can easily classify these as discrete or random. So if you focus on the last one, the outside temperature today, right? You're randomly checking what's the temperature today. So if for example, if you're measuring in Celsius, so it could be 20 degrees Celsius, or it maybe could be 20.33 degrees Celsius. So it could be any number, right? You can't count it, but you can measure it. So the outside temperature is a continuous random variable. Next we have the concept of mean and standard deviation. So mean of a random variable is simply, you can say, its long run expectation, or what is its expected value. Similarly, the variance is variation around the average value. By the way, the reason I am discussing these concepts in brevity and not going in the details is because the basics of arithmetic mean and standard deviation, they are generally covered in introductory courses of statistics. But if you want a video that explains in detail what is arithmetic mean, how do we interpret it, what are its properties, it's highly advisable that on my channel there is another video whose title is Arithmetic Mean of Ungrouped Data, and this is the URL. Of course you can't click during the video on the URL, but if you say, I can post this URL in the comment section if you post your query in the comment section, or you can simply type arithmetic mean of ungrouped data and then my channel name. As I told you that my channel name is Rao Hub, so I can show you here. You see, this is my channel name, Rao Hub. Let me enlarge it a bit. This is the name of my channel, so you can subscribe. So if you type pardon for this disturbance, so yeah, I'll be going back to that slide. Yeah, so if you click on on my channel Rao Hub, if you search for this video arithmetic mean of ungrouped data, you will easily find detailed guidance on what is meant by arithmetic mean, what is its interpretation. Similarly, if you want an in-depth video on variance, so we also have a video on variance, and the title of that video is Quintiles and Measure of Variation lecture. By the way, I recorded it on 6th April 2020, so that's why this is just the date, you can ignore it. And the reason I have encircled here the timestamp is because in this video lecture we have some other concepts discussed as well. So but if you want to focus only on the understanding of variance, you should go to time lapse 18 minutes approximately, and from there you can have a detailed lecture on what is meant by variance, how do we interpret it, right? In short, let me tell you, mean is the balance point of a random variable. For example, if I calculate mean in a particular distribution, so let's say this is the distribution, and for the time being let's forget how is it calculated, but just interpret. If mean is 3.5, that means that I am expecting that the random variable for which this distribution is made, in the long run it's going to balance, or it's going to take the value 3.5. And variance or standard deviation is the amount of scatter or the degree of scatter around this mean. You see, the entire data is not equal to 3.5, the values are different. So how we can express that numerically is captured by the variance, and then the square root of the variance is the standard deviation. So the problem with variance is that it is in the form of squares, so we take square root to balance it, so that the measure of variation is in the same units as of data. Okay, so let's focus. So if we have to calculate mean, we simply find sum of xpx, and if we have to calculate variance, then we find a sum of square of x into p of x minus square of sum of xpx. Maybe you find these formulas a little bit difficult for now, but once we do it with the help of an example, then you will understand. So here again, let me focus on the Excel file. Yeah, so this is the file here that I was discussing. Just a minute so that I can delete this. Okay, so this is the file. This is your given data, right? Let me highlight it. So the data is, you have number of dots and you have the probabilities, and you have to calculate mean. So how you can calculate mean? You simply multiply each value of x with its corresponding probability. For example, if you double click here, you can see I have multiplied 1 by 0.1667. So what you have to do, you have to multiply each value of x or the random variable with its corresponding probability. Similarly, for example, if you click on the second cell, this is 2 multiplied by 0.1667. So once you have this entire column, you simply add, right? Find the sum of all these values, and that would be your mean, right? So this mean is simply sum of this column. And how is this column calculated? column x multiplied by column probability of x. So this is mean. Now if we have to calculate variance, the formula is that we calculate expected value of x square minus square of expected value of x. So what is expected value of x? The mean of x is simple expected value of x. So this is 3.5 is e of x. But we also need expected value of x square. And how I can calculate that? You see I have made another column x square times p of x. So x square means x multiplied by itself, that is 1 multiplied by 1 into the probability. For example, if you see on the second cell, so this is 2 multiplied by 2, that's 4 multiplied by the probability, which is 0.1667. So the sum of this column is expected value of x square, right? This is expected value of x square. So how can I calculate variance? You simply find the difference between expected value of x square minus the square of mean. See, 15.16667 minus the square of 3.5. So that will be variance. And standard deviation is simply square root of this number. So in Excel, if we have to take square root, we type is equal to SQRT and then we insert that cell. So the standard deviation is 1.7. So coming back, this is how we can easily calculate mean of a random variable and standard deviation of a random variable. So I have already told you that if you want in-depth discussion on variance, you can refer to this video lecture on my channel. Next we will do another example. We have data on number of cars being sold, and we have given that the probability that this seller sells 0 cars is 0.1, 1 car is 0.2, and so on. So we have this probability distribution. The question says what type of distribution is this and how you can calculate its mean. So intentionally I'll be focusing only on the mean because I've already explained you how to calculate variance. You can calculate that as well. So I'll be referring you towards an Excel file where we'll be drawing the graph. So here's the data that I've copied from the slide here in Excel, and you can easily, as I said, you can select this data. You can simply go to insert, and you can go to scatter, and then you can make this plot. For the time being I'm not making because I already made it here, right? And how I've added these numbers on the dots, as I've already told you, click on plus and you click on data labels. Then if you check the data labels, then these numbers are shown. Now you can see what type of graph is this. Let me take it in Paint and then I'll explain it there in detail. So this is the graph. You can see that in the center, if this is the center of the distribution approximately, so you can see this is the maximum height, although this is also maximum, but in the center I'm looking for approximate center of the distribution is this. And if you look at the values that are, let me change the color, so let me change the color. So if you look at the values that are equidistant, for example this value and this value, these are like the difference between, let me focus, the difference between 0 and 2 is same as the difference between 2 and 4. So these are the values which are 0 is equally distant from 2 as 4 is distant from 4. So the probabilities are same. If you look at let's say 1 and 3, once again these are equidistant, but here the probability of 1 is different whereas the probability of 3 is different. So why am I focusing on equidistant point? Actually, if the values that are equidistant, if their heights are same, for example if this let's say this value was not 0.3 and this value was also 0.2, right? That is what I'm saying is that these two values were, let's say, suppose same. In that case, we could have said that it's an exact symmetric distribution. What I'm saying, let me type here, that if this was the case, then we would have said that it is exact symmetric distribution. Right? But this is not the case. This is not exact symmetric distribution, because the value against this 3 is not equal to 0.2. It's different. But for these two are exactly same. So we can say that this distribution is not exact symmetric, but it is approximately symmetric. Right? So this distribution is approximately symmetric. Right? Okay, so if I have to explain you further what is meant by a symmetric distribution, for example, if you take 1/2 of this distribution, this is the 1/2, right, and the other half is, you can see here. So now you can see that the other half is not exactly mirror image of the other. Like if this is the 1/2, this is not a mirror image of the other half, so it's not 100% symmetric, but it is, you know, sort of similar, because the only problem is this 0.3. If this 0.3 was equal to 0.2 and this line was not here, I mean this part would have been missing, then these two figures would have been mirror images of each other. So here it's approximately symmetric. Okay. Anyhow, coming back to the concept that we were discussing, whether it's symmetric or not. By the way, if you want, once again, let me tell you that if you want to discuss or understand in detail about symmetric and skewed data, although I have discussed to some extent here, but if you want to go in the details and develop your concepts, so you can watch this video, symmetric data and skewed data histogram for unequal class width, and you can focus on the part of the video where I am explaining the difference between symmetric data and skewed data. Once again, this video is available on my channel Rao Hub. Anyhow, so we have to calculate. So the first part of the question was, what type of distribution is this? So we have already told you that it's an approximately symmetric distribution. The next part says that you have to calculate the mean of this distribution. So as I said, mean is sum of xpx. So you can see I have multiplied x value by its probability. So similarly, for example, x value is 1, probability is 0.2, so 1 into 0.2 is equal to 0.2, and so on. So the sum of this column, it is equal to 2.1. So the mean of this distribution is equal to 2.1. So we have calculated the mean. Now I am not doing the variance, because I have already explained how to calculate variance of the distribution in earlier part of the video. So you can easily calculate the variance and you can verify that it will be equal to 1.29. Okay, so we have another interesting question. We have a question where, let's say, this yellow part is a given data, and values of random variables are given and probabilities are given, but you can see that two probabilities are missing. One probability which is missing is y, the other probability which is missing is z, and we have to find this probability. You see, the question is, find the missing probabilities if mean is equal to 58 and variance is equal to 580. So you have to make use of this given data and this given information to calculate these missing probabilities. So, and how you can do, you see, that mean is equal to sum of the column xpx. So if you construct the column xpx, so that will be 10 multiplied by 0.1, which is 1, 15 multiplied by y, which is 15y, and so on. You can easily multiply each value of x with its corresponding probability to construct this column. Now sum of this column is equal to, if you know, this 1, 1.2, 5 and 0.12. So this is the sum is 7.32, whereas 15y and 30z we can't, you know, express numerically. So I have written that the mean is equal to 7.32 plus 15y plus 30 times z. So this is an expression for the mean. Now, you know, variance is the difference between expected value of x square and the square of expected value of x. So first we calculate expected value of x square, which is equal to x square into p of x. So x square means 10 multiplied by 10 into probability, which is 0.1. So this is equal to 10. Similarly, 15 multiplied by 15, which is 225, multiplied by the probability y. So this is 225 times y. By the way, I have, you know, mistakenly written here that it is y square. This won't be y square, by the way. Let me correct it here. Just a minute. Missing frequency question. Yeah. So this won't be y square. It will be y, because we are not squaring you know, probability. We are squaring the value of x. Similarly, it won't be z square, it will be z. So if I have to calculate sum of this column, if I add all the numeric values add up to be 163.8, and the unknown values are 225y. So let me remove this, and then z square is not there, that's a typo. We should just write z, because remember I said that we are squaring x, we are not squaring the probabilities. So this is the expected value of x square. So let me copy here. Next, what we can say, that it's given that mean is equal to 58. So the expression that we developed for mean here in the Excel file, coming back, you see this is the expression that we developed for mean, right? So what I'm going to do, I'm going to equate this expression with the given value of mean, which is 58. So coming back, this is the expression, I equate it to 58, and then I solve it for y, and I get a particular value of y. Now variance is equal to expected value of x square, which I said it's a typo, we shouldn't have squares here. Yeah, so you can see this is expected value of x square, and how we calculated it. Expected value of x square is 163.8 plus 225y plus 900z. So this is expected value of x square. So expected value of x square minus square of the mean, and the mean we calculated, this is the expression. So either we can, you know, write this expression here, or we can even simply, we know that the value of mean is 58, so instead of writing the complete expression here, we can take advantage and we can simply type 58 square. So now I have this value, and instead of applying this entire formula, I can simply type that this is square of 58 is 58 times 58. Anyhow, so and why I have equated it with 580, because in the question it was given that variance is equal to 580, right? You can see in the question it was given that variance is equal to 580. So you are going to, you know, you have now two equations. From the first equation you have got the value of y in terms of z. So if you put this value here, right? So if you put this value of y here, you can easily solve it, and you will get the value of y, and once you have the value of one variable, you can easily find the value of the other. So this is how you can easily find the missing frequencies, right? So let me, you know, correct the same error in the slides as well, so that you won't feel confused. Give me a minute, I'll simply copy this calculation in the slide. So this is the exact same work that I've shown there in the equation editor. So once you solve these two equations, you can easily find the missing frequency. So this was the example of finding missing frequencies. Okay, so next we have another example. The Pizza Palace offers 3 types of cola. The smallest size sells for $1.99, the medium one for $2.49, and the large one for $2.89. And then it's given that 30% of the drinks sold are small, 50% are medium, and 20% are large. So we have to make a probability distribution, and then we have to tell whether it's discrete or not. We have to compute its mean and its variance. So you can see what is the value of, if x represent the price of pizza, so we are told that the price of small pizza is 1.99 and the probability of sale of a small pizza is equal to 0.3. You can see 30% of the drinks sold are, it's not about pizzas, it's about drinks. So 30% of the drinks are small, 50% are medium, and 20% are large. So the probability of a small drink being sold is 0.3. Similarly, medium one 0.5 and large one 0.2, and these x values are simply the prices of those drinks. So if you add all these probabilities, you will see it is 1. So it's a proper probability distribution. And the reason I'm calling it discrete is because we have only 3 types of drinks: small, medium, and large. So it's not that we are measuring the amount of, let's say, liquid in those drinks. We are simply counting how many are small, how many are medium, how many are large. So we are counting the things, so it's a discrete random variable. Now if we have to calculate mean or the expected value, as I told you that the mean or expected value is xpx, so we have the values of x, we have the probabilities, we will simply multiply 1.99 by 0.3 to get the first outcome in this column. Similarly, we can construct the entire column and add it to get the value of mean. For variance, you need expected value of x square as well. So you're going to square the x column, multiply by the probability, add it. So once you have expected value of x square, you subtract it from the square of the mean and you get the value of variance. Once you take the square root of the variance, it is the standard deviation. So that was just another simple example. Next we have another interesting exercise where they are saying that we are given 3 type of distributions and we have to check that which one of this is a proper probability distribution. If you look at the third one, you see one of the probability is negative, which is impossible. Probabilities can never be negative. So this third one is not a probability distribution. If you look at the first and the second one, all the probabilities are positive, but we need to check whether the sum of the probabilities is 1 or not. So if you add these probabilities in the first distribution, you will see this, it will exceed 1. But if you add the probability column in the second one, so you will see that it is equal to 0.6 plus 0.3, which is 0.9 plus 0.1, which is 1. So the middle one is a proper probability distribution because the sum of the probabilities is 1 and none of the probabilities is negative. None of the probabilities is greater than 1. So this is a proper probability distribution. Now you have find the probability that x is exactly 15. So probability that x is exactly 15 is given, it is 0.2. If you have to find the probability that x is no more than 10, then that means it is either 5 or 10. So I am going to add the two probabilities, 0.1 plus 0.3. So the answer for the second one will be 0.4. The last part says what is the probability that the value is more than 5. So in that case, if you add the last 3 probabilities, 0.3 plus 0.2 plus 0.4, it comes out to be 0.9. So the answer for the third part is 0.9. Now you can easily calculate the mean, variance and standard deviation based on the ideas that I have discussed in the video lecture. We have another example here, and the reason although it's similar, but the reason I'll focus here, for example, you have let's say you are the director of the admission, and the probability that you are going to admit 1000 students is 0.6. The probability that you are going to admit 1200 students is 0.3, and so on. So you have to find expected number of admissions. So what you are going to do, the question says expected number, so you should know that expected number simply means mean. So you will treat this admission as x and probability as p of x, and simply calculate the mean in the similar way as I have just explained in the previous part of the video. So this is the end of the video lecture on expected value and variance of a random variable. So you are welcome to post your queries in the comment section. You can get professionally connected by dropping me an email. I have mentioned my email here, and you are more than welcome to explore the other playlist and support the channel by subscribing and sharing with other viewers through your social media. Thank you.